Hello, Dan here from howtomechatronics.com. In this tutorial, we will learn how to make an Arduino-based robot arm which can be wirelessly controlled and programmed using a custom-built Android application. I will show you the entire process of building it, starting from designing and 3D printing the robot parts, connecting the electronics components and programming the Arduino, to developing our own Android application for controlling the robot arm. Using the sliders in the app, we can manually control the movement of each servo or axis of the robot arm. Also, using the save button, we can record each position or step, and then the robot arm can automatically run and repeat these steps. With the same button, we can pause the automatic operation as well as reset and delete all steps so that we can record new ones. To begin with, I designed the robot arm using SolidWorks 3D modeling software. The arm has 5 degrees of freedom. For the first 3 axes, the waist, the shoulder and the elbow, I used the AMG 996R servos, and for the other 2 axes, the wrist roll and wrist pitch, as well as the gripper, I used the smaller SG90 micro servos. You can find and download this 3D model, as well as the STL files which are used for 3D printing, on my website article. The link is in the description of this video. Using my new 3D printer, Creality CR10, I 3D printed all of the parts for the robot arm. Here I would like to give a shout out to banggood.com for providing me this awesome 3D printer. The Creality CR10 printing quality is amazing for its price point, and what's also great about it is that it comes almost 90% pre-assembled. In order to complete the assembly, we just have to connect the upper and lower parts frames using some bolts and brackets, and then connect the electronic components with the control box using the provided cables. Before trying it, it is recommended to check whether the roller wheels are tight enough. And if they are not, you can simply use the eccentric nuts to tie them up. And that's it. After leveling your 3D printing bed, you are ready to transform your 3D creations into reality. I had all of the parts for my robot arm ready in just several hours. So once again, big thanks to banggood.com, and make sure you check out this 3D printer in their store. The link to it is in the description of this video. Okay, so at this point we are ready to assemble the robot arm. I started with the base, on which I attached the first servo motor using the screws included in its package. Then on the output shaft of the servo, I secured a round horn using a bolt, and on top of it I placed the upper part and secured it using 2 screws. Here again, first goes the servo, then the round horn onto the next part, and then they are secured to each other using the bolt on the output shaft. We can notice here that at the shoulder axis, it is a good idea to include some kind of spring, or in my case I used a rubber band to give some help to the servo, because this servo carries the whole weight of the rest of the arm as well as the payload. In similar way, I continued to assemble the rest of the robot arm. As for the gripper mechanism, I used 4mm bolts and nuts to assemble it. Finally, I attached the gripper mechanism onto the last servo and the robot arm was completed. The next stage is connecting the electronics. The circuit diagram of this project is actually quite simple. We just need an Arduino board and an HC05 Bluetooth module for the communication with the smartphone. The control pins of the 6 servo motors are connected to 6 digital pins of the Arduino board. For powering the servos, we need 5 volts, but this must come from an external power source because the Arduino is not able to handle the amount of current that all of them can draw. The power source must be able to handle at least 2 amps of current. So once we have connected everything together, we can move on to programming the Arduino and make the Android application. So first we need to include the software serial library for the serial communication of the Bluetooth module, as well as the servo library. Both of these libraries are included with the Arduino IDE, so we don't have to install them externally. Then we need to define the 6 servos, the HC05 Bluetooth module, and some variables for storing the current and the previous positions of the servos, as well as arrays for storing the positions or the steps for the automatic mode. In the setup section, we need to initialize the servos and the Bluetooth module and move the robot arm to its initial position. We do that using the right function, which simply moves the servos to any position from 0 to 180 degrees. Next, in the loop section, using the Bluetooth.available function, we constantly check whether there is any incoming data from the smartphone. If true, using the readString function, we read the data as string and store it into the data_in variable. Depending on the arrived data, we will tell the robot arm what to do. Let's take a look at the Android app now and see what kind of data it is actually sending to the Arduino. I made the app using the MIT App Inventor online application, and here's how it works. At the top we have two buttons for connecting the smartphone to the HC05 Bluetooth module. Then on the left side we have an image of the robot arm, and on the right side we have the 6 sliders for controlling the servos and 1 slider for speed control. Each slider have different initial, minimum and maximum value that suits the robot arm axis. At the bottom of the app we have 3 buttons, save, run and reset, through which we can program the robot arm to run automatically. There is also a label below which shows the number of steps that we have saved. Nevertheless, for more details how to build applications like this using the MIT App Inventor, you can check my other detailed tutorial for it. Okay, now let's see the program or the blocks behind the application. First, on the left side we have the blocks for connecting the smartphone to the Bluetooth module. Then we have the sliders blocks for the servo position control and the buttons blocks for programming the robot arm. So if we change the position of the slider using the Bluetooth function send text, we send the text to the Arduino. This text consists of a prefix which indicates which slider has been changed, as well as the current value of the slider. So therefore, at the Arduino, using the startWith function, we check the prefix of each incoming data and so we know what to do next. For example, if the prefix is S1, we know that we need to move the servo number 1. Using the substring function, we get the remaining text, or that's the position value. We convert it into integer and use the value to move the servo to that position. Here we can simply call the right function and the servo will go to that position. But in that way, the servo would run at its maximum speed, which is too much for the robot arm. Instead, we need to control the speed of the servo, so I use some for loops in order to gradually move the servo from the previous to the current position by implementing a delay time between each iteration. By changing the delay time, we can change the speed of the servo. The same method is used for driving all of the axes of the robot arm. Below them is the save button. If we press the save button, the position of each servo motor is stored in an array. With each pressing, the index increases, so the array is filled step by step. Then, if we press the run button, we call the run servo custom function which runs the stored steps. Let's take a look at this function. So here we run the stored steps over and over again until we press the reset button. Using the for loop, we run through all positions stored in the arrays, and at the same time we check whether we have any incoming data from the smartphone. This data can be the run or pause button, which pauses the robot, and if clicked again, it continues with the automatic movements. Also, if we change the speed slider position, we will use that value to change the delay time between each iteration in the for loops below, which actually controls the speed of the servo motors. In similar way as explained earlier, with these if statements and for loops, we move the servos to their next position. Finally, if we press the reset button, we will clear all the data from the arrays to 0 and also reset the index to 0 so we can program the robot arm with new movements. And that's it. Now we can enjoy and have some fun with the robot arm. I hope you liked this video and learned something new. Don't forget to subscribe, and for more tutorials and projects visit howtomechatronics.com.